I don't know why I typed that. Can you hear me? Obviously not used to this. Hard to see, but sketching out valve ideas. Yes. It's floating. Get rid of this. It's not correct. Is this John? Have any questions? I'm just looking for a piston I was working on yesterday. Upgrades you would be doing, but I'm sure I can. So for the Taiwan damper upgrades, I have actually just received the prototypes. I made new. So this is a EC jet, straight through hole, if you can see that. But so that just means when you put the, I don't know, stop me if I'm explaining things you already know. Needle. Oh, shit. I thought you did. The view over to more, yeah, okay. So I can take the needle out. I don't know if you stop me if you've seen all this, but the needle design for BC is really annoying. And I think that's coming out. So the jet is just a through hole, and that means that flow can go in both directions. And that's why a single adjuster from BC adjusts compression and rebound bleed at the same time. I am adamantly against that because you adjust compression and rebound bleed for different reasons, and you shouldn't be doing it simultaneously. It's just cheap and easy. You just have a through hole and you have an adjuster, and you can call it a two-way, which from a branding standpoint is probably all they care about. So when you click your adjuster, you're just controlling how much this crappy needle profile goes in and out of the hole there, which meters flow and affects your rebound and compression curves at the same time. My adjuster is designed now with a check valve, which they're so small. Not supposed to be just sitting around playing with these things. See if you can see how tiny that is. Really, really, really small. It's I can't remember what diameter. 5 mil, roughly. Extremely tiny, but this is a little piece. If you look on my Instagram, I think I posted on Facebook too. I was doing CFD on to make sure that it's not too restrictive even when it's open, because you want it to be as free flowing as possible when it is open and then shut as fast as possible. And so that will limit travel or limit flow to one direction only. And I can design this to work both ways, or one way at a time, or both ways, so that you can control either rebound or compression individually. So for this particular design, you will only be adjusting rebound bleed. Then it's actually relevant what I'm doing right now. The seals that BC uses are rubber. Can't think of the actual material right now, but they're basically rubber. You can see these big black. It's actually a combination seal and wiper in one unit. It's elegant, it's easy, it's extremely cheap. These are less than $1 a piece in high volume. But this is the main reason. Well, it's a very, very big reason they have way, way too much friction and a lot of stiction. So they're I don't even want to say OEM quality. I guess they're cheap OEM quality because they're definitely OEM grades to dampers. There's some really good seals for OEM dampers. This is not one of them. But easiest thing in the world to do is to swap this out for something like a U-cup that would immediately have an impact on friction levels and still have OEM level of durability. The extreme case would be a Penske design where they just use a Viton O-ring. And that's why, and not only just a Viton O-ring, we did the tuning when I was there, actually wanted to reduce friction even more. So we went back and forth on the lathe, I don't even know, 10 times, taking a thou or two off as little as we possibly could to get friction lower without it just dumping oil. And they're at a point where everybody knows Penske's weep. So if you let the car sit for a while, or maybe it gets too cold, you'll see some oil leak out. But friction is insanely low. Um, and then there's some other trick seals, and one of them is they go by different names, but Parker calls them flexi seals, and that is the style of seal that is used in F1. They are very low friction for sure. I don't know how they're going to perform yet on a street car, but I'm putting it on mine. So that if it's not too bad in terms of leakage, that will be what will go into the BC um, builds. The reason for that is because I do actually want to make that as much of a standard as possible on all future PDV racing shocks dampers. So they are expensive, but they're not insane to the point where I can't utilize them. And maybe as an upgrade option, but ideally as standard. Then what else? I am probably going to, I got to get a quote. I don't know what it's going to cost yet, but I'm probably going to ceramic coat their rods. Ideally, I would like to turn their rods down for most of the assemblies because they standardize everything as much as possible. And when they do that, they are using extremely large diameter rods when they don't need to in some cases. So that's a strut, so that's justifiable. It's a 20 mil rod from a Volvo S60R. I want to say, I can't even keep a track anymore, but I want to say they have 16 or 18 mil rods when they could be getting away with 12, just based on the application and the position of the car. Like it's a rear damper on a lightweight, whatever. But the rod is oversized because they want to use a standard. And what that does, obviously, is combined with their very poorly managed gas volumes, rod force is through the roof, very high. It increases friction both due to the diameter of the rod, but also the high pressures that they built their dampers to. And just turning down the rod, changing out, because I'm changing the seal anyways, I have to make a new shaft bearing. So that gives me the opportunity to change the rod diameter. I don't know if I'm going to do that. It may not be that much more expensive, but I definitely do want to do the ceramic coating. I want to do some with and some without because I certainly want to get that before and after data, and see how that affects friction as well. Then the other thing, I have to get into these dampers more. So I haven't even torn mine apart yet because I don't have the parts to do it yet, and I didn't have the dyno until this week. So now I can start tearing mine apart and the shock bleeder, and start looking at how they set their floating piston. Their gas volume is really bad. Their gas pressure is really high, and I'm assuming that they also use some basic, scalable, unintelligent way to set their floating piston position, which means it's not optimized. And I could also potentially redesign the piston and the cap at the end of the body, which I can actually open the models I have of my dampers. maybe I can at least show you while I'm talking as well. 30. Yeah, that's a good one. So this is the F30 rear, which is my rear design. Reverse engineered as much as possible. So externally, it's extremely accurate. Internally, because I haven't taken it apart yet, not there yet. But in terms of gas volume, this is my own piston design. I've carried over from some stuff I've done before. But I can redesign this to give more gas volume, and then I can redesign this cap too, because I have so much space down here. I can make that cap huge and add a bunch of gas volume, which will just mean that throughout the stroke, the gas pressure changes much, much less. So at least, even if you have high rod force, it's consistent from full jounce to full rebound, as opposed to ramping up like crazy as you stroke the damper. So all of these things are just in the name of lower pressure, lower friction, more consistency, and then just eliminating the stupid double adjustable scenario here. The other thing I do want to do, which it's so much more expensive than it needs to be, because their needle is very unique, I should say, compared to non-Taiwan dampers. I'm sure most of the Taiwan dampers are the same. They have this, it installs from internally, and it's very long, very thin, so it's probably pretty hard to machine to tight tolerances. And it threads in at the bottom here. But the problem with it is the needle profile is awful. It's just each click is very, very nonlinear. And if I remember correctly from, I can pull that up too. Actually, I don't know if you've seen my turd polishing videos from 2 years ago. Oh my God. Talking through the design and you can't see it. See, this is my first real live. Nobody actually really joined yesterday. Oh, where's my... BC. Nope. Nope. PT. It's not in there. There it is. Let's see. I'm sorry. What did you say? Have you ever check the screen view again? You make them true double adjustable. Also, yes, I saw the other. Okay, so then you've seen one of the videos I walked through this, and this one here is what I'm talking about, where you've got 15 clicks that do almost nothing, and then you have 15 clicks that make a massive change. And that is completely due to this profile that they have. I have a profile. Yeah, I went over that as well. This is a profile I came up with after I left Penske that clearly is just from full soft to full stiff, extremely linear, and there is a little tightening up at full stiff, but I'm probably going to work on that a little bit, although I do have a curve I can just machine right now that would be light years better than this crap that they put into every damper. Let's see, check this out. Can you make true double adjustable? So I can. And are you talking double adjustable bleed or a single adjuster bleed and a canister with a head valve? Let's rebound and compression. So just so we're clear here, that's not even a good graph. So the bleed adjuster, let me sketch. My computer's so laggy today. All right, so what you can see here is this bleed adjuster that I had from years ago. It's actually a little bigger than I was targeting. It affects too much range out here. So you can see there's kind of the bleed chokes roughly there, whereas I would like to be ideally more like here. I'd be choking off, and after that happens, then you can see the main valving takes over, and even though the lines are higher up, well, in this case in rebound lower down, which means higher force, they're all parallel, so it's the same damping rate. Nothing's changing there. What's changing is the damping rate in the low speed. So I can make a valve or a double knob on the eyelet that would also change this, so it would still be flat in the high speed, but it would change the low speed region. Or I can make, I'm not going to get into making a high-speed rebound adjuster for this project. It's too much time involved. But I can adapt an old design I have that would change the slope of this, the compression high speed. Understood. But the compression high speed is more expensive, more difficult, obviously requires well, I shouldn't say obviously, but there probably isn't room in the tubes that BC supplies because they're so standardized and crappy that you can see in my rear here, once it zooms out, there's all this wasted space down here. If that was available on my car, I could easily fit an internal head valve or base valve, whatever you want to call it, that would change high speed that you could adjust. But in order for me, there's no way that will fit in the tube that they supply with the car. So I would have to replace the tube as well. So essentially, I'm replacing the entire damn thing. And because, at least for right now, with the deal that I'm doing for the people that reached out, where I'm doing all of these upgrades for free, I would not do that. That would be too much work, too expensive, and really the work side of it, where I have to get these special dampers done for the pro team that I'm working with. I'm under crazy timelines, so I do have to limit it a little bit just based on time. What else? That's probably it. I have measured their tube surface finish. It's good. I mean, it's hard to screw that up just because it's a steel tube. And even just extruding it is good enough without having to do any secondary finishing. Understandable and bang for the buck and offer feel coilovers. So I have 3 takers on my deal. One is BC, one is hold on, I don't want to show their info. One is Fortune Auto and one is ISC. So BC, ISC, and Fortune Auto are the 3, which that alone is going to be painful because I'm sure they're all going to need different tools just to open them up. But I am very excited to dig into Fortune Auto 500s because they charge so much money, and I'm pretty sure they're going to be the same garbage inside as all the other ones from Taiwan. That being said, if you watch this at any time in the future, I'm talking to anyone other than the one person on here now. If you have a brand, maybe I'm not going to tear it down and rebuild it, but if you want something dynoed, and dynoed in a way that is very informative as to how the damper actually performs and not just a PVP, and I'm open to receiving those if you pay for shipping, all that stuff, and I will run it on the dyno and do the tests and give you the data and share the data online. If you want to do that, that'll be up to you as the owner of the dampers. Let's see, the feels look. So how you see the fortunes, it seems steel is even fancier. I don't know about feel. I know I'm pretty sure Fortune buys their head valves from Penske. I believe they've been doing that for well over a decade now. Pretty sure that's who was doing it, is still doing it. I don't think, maybe as an upgrade they buy Penske internal pistons, main pistons. I don't think they do, or at least for all of them. Again, maybe as an upgrade. But I guess I'm about to find out. I will say this: I know I don't pay attention to what other damper companies do, other than just because I have BCs, because I wanted to do this upgrade thing. I don't know what anybody else does for the most part. I have a couple anecdotes from when I was at Penske where we actually disassembled competitors' dampers, and that's like 2 ever, and mostly because they were already crashed or something to begin with when they were delivered. So I don't know what anybody does for the most part internally, other than lately I've been had some people telling me what other people are doing, so I'm learning now. but I generally don't care too much. Other than I did discover, this is how ignorant I am. Until 3 months ago, maybe, I had no idea that KW, what do they have, V1, 2, 3, and some V4s maybe are twin tube dampers. They do not advertise that at all, but I was floored at the prices they charge for twin tube dampers. And obviously, some of the curves I've seen are awful, which is why they share PVPs and not CVPs and other more interesting tests. M4 GTS. My understanding is anything from a V3 or below is a twin tube. Doesn't matter what car it is. I actually had more people pop in yesterday. I haven't seen anybody pop in. Although it's Easter at 10:39. What am I saying? I was doing it at 1 o'clock yesterday. Okay. UB says drop the F30 even at max height from the. Did it drop the F30 even at max? Oh, yes. I actually had to drop it more than I even wanted to. I can actually, hey, why not unveil this a little bit, even though it's not posted. I can share this and walk through it. This is actually, I don't know if you're on the F87 forums. I shared a little bit of this, and man, such a misunderstood thing. Um, so the BC, like the one that's on the screen in CAD, let me see if it's obvious. Yeah. So I did not want to. You can see even the thread doesn't go all the way to the top here. I think I saved 50. What is this? 43. Yeah. So even less than that. So maybe 30 mil. And I could go longer than that, but basically, because the rod is as long as it is, which for me, I would have preferred it's a little longer. And the body, I could not extend. I didn't feel like I could safely extend it further and reduce thread engagement. You probably could a little bit more, but so I was essentially limited to what you see on the screen, and that required me to lower the car more than I wanted. And most of the data in here is actually the default to this page is actually my calculation, and um, what that meant was my where's the right head? Oh, I need to actually enter the. I forget what the OEM or total stroke was. One second. OE exposed length is 179 versus 140. Let's see that. Oh my god, so bad. Yeah, so that's where that came from. And OEM, what did I just say? That was 179. That came from 179. Yeah, 179. So 7.05. Ride height change at the wheel. 5 inches. Yeah, that's not right. This is why it's not posted yet. This is my own local HTML page that is not online. But the point of this is that I was specifically targeting a percentage of jounce travel, and that could be a percentage or a hard number. But if I want to look at the amount of jounce travel that is typically on an OEM, but also this is pretty close to what the rear BMW had. It's roughly 55, maybe it was 52, something like that. Of the available stroke is how much you have at ride height, at OEM ride height. And then obviously when you lower the car, you are just taking away from jounce travel. So something's wrong with my calc here, but this is saying that my setup lowered the car. So this is ride height change at the wheel based on the shorter overall exposed rod length. And 55% of that length is assigned to jounce travel at ride height. That would mean that the rear car itself has to lower 5 inches. Wrong number. It's more like 0.6 or 0.65 inches. I was actually trying to lower the car half an inch all around. So I couldn't even do that. Definitely can't do actual ride height. If I see that sometimes with people that just want to coil over but maintain ride height, can't do it. So let's see. Yeah, I answered your question and then rambled on. Yeah, so I'm working through that with the one customer that does have BC dampers. We've roughly decoded their part numbering system, so when you can order just the, I'll call it the hydraulic assembly, which is just the everything that's wetted with the rod. And the part number system is, it clearly tells you things like the length of the body, the amount of stroke, the diameter of the rod, and I think the diameter of the tenon or the thread size of the tenon, I forget. So you can go through their website and search for things that are close, and we've been trying to do that. We think on the front we can replace the hydraulic assembly for the strut with a longer one, and that will allow us to optimize the overall length and stroke and amount of gas volume for the front. For the rear, I'm advising him that we don't do that because on the rear of his car, the rod tenon is unique. So it's not just a shoulder with a thread or an adapter like mine has. It's it's got a very long reduced diameter tenon with two big washers. It's a E90 if you're familiar with it. So there isn't going to be, or it's highly unlikely that there's going to be another assembly, hydraulic assembly, that gives us more stroke, more body length, and still has that same rod tenon that will fit on his car. I could obviously just order, well, he's supplying them, so he could just order longer assembly from something else and also order the one that's meant for his car, and I could swap the rods. But that just becomes expensive, and he probably doesn't want to do that. I will say, most of when I see posts, especially after going through all this with mine, and the ride height issue, which, like, there's a lot of companies like BC and big name ones too that will, in their instructions, tell you to just preload the spring 5 millimeters, and that is completely wrong. What that often does, depending on your spring rate, is will leave you with far less jounce travel than you should have at your ride height, because you adjust the body length. And well, they tell you to adjust the body length after you've preloaded 5 millimeters to change your ride height. And what that tends to do is it just gets you your ride height you want. You think you're fine, but you're actually just sitting on your bump stop and just crashing over the smallest bumps instead of actually using the damper. You'd be surprised how many people don't. It's simple math, though. Can I actually lay it out here? Byline 363. Okay. Something's not aligned right here. Well, you understand, so that's okay. I was looking for my solid pistol. Don't know where it went. Yep, there you go. I don't know if you've seen it. The Australians, the engine tuning school. I can't think of the name. And they have a whole course on setting up your suspension. They do, yeah. There you go. They have a whole course on setting up your suspension. They go over this in detail, but they had a Instagram reel, so it's only less than a minute long, where they specifically show just that part and what happens. It's a really good graphic. I made a piston yesterday and I crashed, and I guess I lost. It was a max version. Just toss it. Yeah, probably. I'd be surprised if they also changed the exposed rod length, but maybe they do. I don't know what I need to be here yet. That's kind of silly, but understandable. You're trying to be at stock height? Definitely. I think that's the one I watched yesterday and today. I didn't actually even finish it. There's actually on my screen. Secrets match. Yeah, that's the one. I'm hearing a lot of interesting things about Nitron, and I certainly have my opinions about semi-active valves. What do I actually want to say about it? Let me ask you this: what did you think of the video? Drag race the car, so good. Look at this one. You're not bad. Sweet. That's a good one. That's yeah. I don't know what they charge. It's definitely up there. Yeah. So when I see those videos, I still kind of get a little frustrated. Center on there. That will control that. Yeah, there we go. So from most, I watched 3/4 of it, I guess. The they never showed it actually running live. They just showed PVPs basically. Maybe I missed it, and I'll pull it up right now. Which is just, whoops. It's just, I don't know, it's frustrating because people just see that range and they think that's what makes it good. But from an actual performance standpoint, that I don't want to say it means nothing. It definitely means something what your PvP. I mean, I'll say it this way: the closer your CVP is to your PvP, which is perfect straight lines, the better your damper performs. But that's not what happens because you have all types of compliance that a good damper tries to design out. But part of the reason uh, companies don't want to show that is because that's either their secret sauce or they stink and they know it and they don't want to show how bad it is. Um, and I don't recall seeing any CVP plots or actual live dyno runs on that video. So it just supports my understanding of um, their real quality level and I shouldn't say quality, but performance capability. It's a nice, fancy looking, semi active. Um, so I take it at that. It's not something I would ever buy. Uh, Good enough. What material I choose will depend on the body material. That's not true. We're talking about balls to the walls. So, hmm, seems like not much of it. I think it was a touch something. The ideal piston for this ultra awesome damper will come down to FEA. So I don't know what material it needs to be. We'll call it 7055 for now. Hmm. Yeah, exactly. um, I don't know. I battle a little bit with what to show. Part of my my first um, my gut reaction is show everything that I know isn't proprietary because I just don't care that much. Um, if what I show ends up being copied by a competitor, okay, whatever, I guess. That's what they're all protecting against. They do not want, if they actually have something good, they don't want to give that away. From my standpoint, I've just spent 7 years working on highly proprietary active suspension. Um, and I view this entire market as what's the right word? it's not really a joke. It's there's no such thing to some extent anymore in passive dampers as um, um, trade secret. Um, Everybody patents the tiniest little thing because they want to try and claim that either from a marketing perspective they are doing advanced engineering or scare away anybody that ends up copying or just comes up with that similar thing on their own. Um, Even though most people don't prosecute their patents. Um, like when I was developing a hydraulic rebound stop, which is really nice. I think it's something I do. I definitely want to test some of that on some race cars. Um, when I had to do this deep patent search and change my design to navigate through all these different patents. And in that patent search, I was finding companies that were violating other companies' patents. So clearly, nobody was suing anybody, and I still avoided doing that and came up with a design that is more similar to a patent that expired. It was developed in the 80s. Um, but it was just like the dumbest things, the dumbest little changes were patented because everybody's so damn protective of uh, I don't want to say unimportant either. It's just silly to me for something where OEMs, especially, they're just in a commodity market. Like dampers are so freaking cheap. They don't care about performance, but then they patent the shit out of any little thing they can come up with. It's funny, and I just don't care. Um, yeah, I don't know. So I'm sharing way more than any damper company would. Um, Oh, where do I want to put this? I'm still figuring out my file system for this company. I don't know where I want to save this. Uh, oh yeah, that's what I did yesterday. This is a piston. Call it 3614 solid. Good enough for now. Hmm. Would you guys want to upgrade this? What cars are those? I did not limit it, but I am being selective. So if just because it's free, I need to make sure that there is value for me in what I'm doing. Um, the one is a Ford Fiesta ST, which the value there is that one's the Fortune Autos. And the other one is don't bother me. It's a oh, it's another BMW. an old one, 92 E36. Oh. Good enough. And a little bit of a rock and a hard place on this one. What is it? It's way too big of a gap. What's my opinion on the F80X EDC charge? I don't have one. I don't remember what they look like, and I'm just not really paying attention to anything semi-active right now. It's something I want to get into, but I also want to make sure when I do, it's actually high performing. And most of these are not that. In the little experience I have, their response times that they claim aren't even true. That's one of the more recent areas that everybody tried to patent every little thing they could. So those patents are still in force, and there's not a lot of wiggle room there. But I do have a pretty good idea of what the best valve available is off the shelf, and integrating that is a possibility. The complexity there is how do you program it and just get it to integrate with the car the way I would want to. I'm not an electrical engineer. I'm not a mechatronic engineer. So it's just not my forte. I'd have to bring people on to take that project on. I really think I'm going to go down in body size. You can actually see this is so far from complete in terms of sizing, but the inerter gears I have right now just have something floating in space to start visualizing where they're going to go and how to get flow to them in the way that I need to. Assembly. Well, I guess I do have an opinion on any factory EDC chart. It's probably garbage if you're trying to race, no matter what they claim. Maybe other than Porsche. Porsche has proven to be unique, although it's not something I haven't looked at the data or anything. I've worked directly with them and I know how they operate. So they are incredibly focused on performance. It's was refreshing. I can say that much. Uh, mm, don't be scared. What's your question? Yeah, that's generally the philosophy I believe in. I will say believe in for now. I am not a shock tuner yet. That's something I obviously will need to become very experienced in. But I've certainly been around them and some of the best in the world. Um, and even though what you're talking about is a digressive curve, even though I thought I wanted a digressive piston on my Corvette. Um, I was pushed by one of the best at Penske to get a high flow with dish. So the shims do preload just because um, the the end faces of the piston are actually have a. It's impossible to see here, but these faces are. Um, they have a 1 degree to a 4 degree dish. So it does add preload, which does allow you to build your low speed nose up a little bit before it blows off and you hit a lower um, damping ratio on the high speed. That car drove so unbelievably well. I will forever. I want to get that car again just so I could build those dampers just like that again and daily drive that Corvette. It was better than anything I've ever been in, and that has to do with the quality of the damping, but also the reasonably digressive curve that I had and the spring rates, um, and the tire. To be fair, I do like a meaty tire, but it was it was stiff. It was not. I forget what my wheel frequencies were, but like my rear springs on the vet were uh, at least 900 pounds per inch. Yeah, I converted to coilover too. But the the dampers were so good. It was. I'm still shocked to this day. I've never been in anything like it. um, but that was really just a toned down version of what I thought I wanted, because I thought I wanted a hardcore full digressive build. And what was explained to me is that it's it can be very good, but generally um, not for the street. Um, Now that was that 20? It's probably 2015, so 10 years ago, and there's just a lot of conversations like that. I just don't remember all the details. So exactly why and what type of track he recommended that day for a digressive piston, I don't remember, but um, it has its use in certain places, and in Penske's experience up until that time at least, it was not for street cars. Now that being said, you can tune a digressive to not be that digressive. It's entirely possible. So uh, just because you have a digressive piston doesn't mean you have some crazy blow off. Um, this is another piston. Nope, what am I doing? That's not saving. I'm gonna have to think about what to call these things later. I This is where I just don't know uh, what other people are doing, but I believe Olins has um, multiple piston types, including digressive. I don't know what they would actually ship in like a standard R&T kit. um, but any of the race stuff, I'm sure they have other options to choose from. No. Inch adhesion, 16-inch adhesion, or 16 millimeter. That's a great question. Um, I can say that if I had everything ready to go right now, manufacturing would take uh, I'll guess a month and a half. It's gonna be plus or minus 2 weeks on that probably. And then what I don't have, I can't even start designing tools to take it apart until I have them in my hands because I have no idea. Um, there's very little that probably carries over from my BMW dampers. So any tools I could start designing right now, I really can't until I have those. Uh, they're just going to be different enough. Um, and so I've been going back and forth with him on the setup, the general setup. So he's got very, very, very high wheel frequency in the front relative to the rear, which I was not expecting when I started this. And I want him to be happy, and he says it's very close to a previous setup he's had that he was very happy with. So it goes against a lot of what I would do, but there are probably some valid reasons for it that I don't have the experience to push back on yet. So we've been going back and forth on that. I think we're settled at this point on what spring rates. He knows what roll bars he's getting, and we know the roll bar rates. And I've gone through building out my calculators to basically set up his car and understand what that setup means in terms of uh, pitch, pitch and roll, um, weight transfer numbers, just based on a lot of reasonable but still estimates, not measured data like CG height. Um, Obviously, we know track width and wheelbase, and he's got to get updated corner weights and unsprung weights, but those numbers aren't sensitive enough. The outputs aren't sensitive enough to those that it's going to matter much based on the Google AI results of what his unsprung weights are and stuff like that. So it's a pretty robust calculator. And part of why I'm doing this is to build out these calculators and then take that data and ultimately bring that into a damper curve design calculator. And um, that will be what drives what I build his dampers to, at least initially, and then we can iterate because I'll obviously do rebuilds based on his feedback just to make sure, well, to fine tune my calculator so that future builds are more accurate. Um, so we've gone through most of that process and we're ready to start actually ordering parts. What's really taking precedent right now is even if those parts were here today, I have to keep chugging along on this assembly for the team that I'm working for because I am running out of time very quickly to make their first track test. I didn't really answer that. The nice thing about this is he is very accommodating. He has a running car with JRZs, and he's got to get a new motor installed. So he's not in a rush either. So it's likely I won't be giving him anything to install until I'm done my testing with the protein in supposed to be July. So factoring in design time, delays due to the other work, manufacturing time, it's probably going to end up being midsummer. These notes are so bad. What part did I have to? Thanks for joining. Thanks for telling me to get on. I was thinking about it, but figured it's Easter. Nobody's going to join. As soon as I saw you, I hopped on. I'm sure we'll be talking online. And yeah, I'm hardcore trying to launch this company. So I'll be posting as much as possible. Thanks. Mm. probably would be good to set the overall length of this thing. Hmm. What? Shit. No. $26.373. Oh. Don't know what I did right there. Man, this thing can be so short. Well, that was a lovely 2 hours. Uh, this is saved forever, so hopefully people enjoy this in the future. Certainly had a good conversation with Swaggin65. Over and out.